Hey friends, welcome back to Civil Engineering Mastery. In this video, let's solve one frame problem using methods of joints. I have already uploaded few videos about what is truss, basics of truss, and how do we consider the member, like whether it is a tension member or a compression member. Everything I have explained in detail in few other videos. I will give you the link in the description box. You can check that one if you want. It will be very useful if you watch that video to understand the basics very clearly. So without further delay, let's begin with the problem. First, let's understand the problem. We are having 1, 2, 3, 4 joints and 5 members. 1, 2, 3, 4, 5 members. And first we need to find out the angle. Here the angle is not given. We need to find out the angle. And second one is we need to draw the free body diagram of this frame. And next one is we need to draw the free body diagram of each joint. So first we need to find out the angle, second one free body diagram of a frame. By using this we have to find out the unknown reactions, support reactions, and by drawing the free body diagram of each joint we are going to find out the unknown forces at each joint. To find out the angle, let's consider the triangle ACD. This angle is theta and this angle is alpha. So we know the distance. This is half the distance from here to the center, 3 meter, and this distance we know. So from this we need to find out the angle. First let's find out theta. So if we consider tan theta, it is 3 by 3. So theta is equal to tan inverse of 1, which is 45 degree. And similarly, if we consider tan alpha, it is 6 by 3, which is 2. Alpha is tan inverse of 2, which is 63.4 degree. Now we got the two angles. 45 degree, theta is 45 degree and alpha is 63.4 degree. If we know this angle, then only we can find out the unknown forces at joint A and C. Similarly, if we know the angle theta, then only we can find out the unknown forces in the member AD. To find out the angle, let's consider the triangle ACD. This angle is theta and this angle is alpha. So we know the distance. This is half the distance from here to the center, 3 meter, and this distance we know. So from this we need to find out the angle. First let's find out theta. So if we consider tan theta, it is 3 by 3. So theta is equal to tan inverse of 1, which is 45 degree. And similarly, if we consider tan alpha, it is 6 by 3, which is 2. Alpha is tan inverse of 2, which is 63.4 degree. Now we got the two angles. 45 degree, theta is 45 degree and alpha is 63.4 degree. If we know this angle, then only we can find out the unknown forces at joint A and C. Similarly, if we know the angle theta, then only we can find out the unknown forces. Next, let's draw the free body diagram of the frame. At joint A, we are having hinged support, and joint B, it is roller support. Due to hinged support, we'll be having reaction RA and HA. RA is the vertical reaction and HA is the horizontal reaction for this hinged support. Similarly, we'll be having vertical reaction for roller support, that is RB. So we will be having only 3 unknown reactions, unknown support reactions for this case. So how do we find out the support reactions? By solving the equilibrium equation, that is summation of Fx is equal to 0, summation of Fy is equal to 0. Similarly, summation of moment is equal to 0. So these 3 equilibrium equations are used to find out the support reactions. Next, let's draw the free body diagram of each joint. First, let's consider joint A. Joint A will be having the member AD and AC. So at joint A, there are 2 unknown forces. One is FAC and one is FAD. So you have to remember that we are going to calculate the forces, unknown forces at each joint, not in the member. So for example, here I have considered this member as a tension member. For every action there will be an equal and opposite reaction. So here if this is a tension member, this will exert a force on the joint that is acting away from the joint. Similarly, if it is a compression member, that will exert a force on the joint which will be acting towards the joint. Now the confusion arises like how do we assign whether the member is a compression member or a tension member? Choose like whether it is a compression member or a tension member initially, and after that once calculations are done, we can come to know if we get a positive value, then it is a tension member. If we get a negative value, then it is a compression member. Next, let's consider joint B. Joint B, we are having two unknown forces, that is FBC and FBD. And joint D, we are having three unknown forces, FDC, FDA and FDB. So this is how you have to draw the free body diagram. See, these forces are at joint. So only these internal forces we are going to find out. As I said before, here I have assumed all the members are in tension. Then after that, once the calculations are done, if we get a negative value, we can come to know that our assumption is wrong, because whatever I have assumed is tension, so I should get a positive value. If I get a negative value, then that becomes a compression member, we can change it. And if we get a positive value, then it is a tension member. So this is how you have to find out how to choose the member as a compression member or a tension member. Let's find out the support reaction. The equilibrium equations are summation of Fx is equal to 0, summation of Fy is equal to 0, summation of moment is equal to 0. Here summation of horizontal forces are equal to 0. So here HA is 0. Next, summation of vertical force. So we have one vertical force here, external load. So unknown forces are RA and RB. Apart from this, this is known load, and this one is unknown RA and RB. Two unknown forces are there. RA plus RB is equal to 10 kilonewton. So the total of these two vertical load is equal to the total load 10 kilonewton. Summation of moment is equal to 0. By seeing this geometry, we can easily say that the load will be distributed. This external force will be distributed to this RA and RB. Half of the load will go here, half of the load will go here. But still I wanted to show you how do we need to take the moment at about the axis. So taking moment about A and equating the C. So minus RB. Here you have to be very careful with the sign conversion. Clockwise is positive, anti-clockwise is negative. Similarly, upward direction is positive and downward direction is negative. So here this is anti-clockwise. So minus RB multiplied by 6 plus 10 multiplied by 3 is equal to 0. So by solving this, we get RB value is 5 kilonewton. As I told you, half of this load will go to this joint and half of the load will go to this joint. So we know now RA is 5 kilonewton and RB is 5 kilonewton. Next, let's consider joint A, resolving the forces horizontally and equating the. So here also we will be having three equations, equilibrium equation, summation of Fx is equal to 0, summation of Fy is equal to 0 and summation of moment is equal to 0. Here there will not be any bending moment, so we don't need to consider the bending moment is equal to 0. Only we are going to resolve the horizontal forces and vertical forces. So summation of H is equal to 0. Sign conversion is very important here. Upward is positive and right side is positive. Similarly, negative is left side is negative and downward is negative. We have to keep this sign conversion in mind while calculating the unknown forces. So at joint A, we are having two unknown forces, that is FAD and FAC. So we know the angle and this is our support reaction. So from this we need to find out. So here I am telling you this FAC we are converting into FAC cos 63.4 degree. Similarly, this FAD we are converting into FAD cos 45 degree. So let me tell you how we can take this. So here we have to remember the basic trigonometry. Consider this triangle. This is angle is theta and this is ZXY. So if we consider sine theta, it is y by z. If we want to get the value of y, then it will become z sine theta. So this is how we need to convert. Vertical force means sine theta will come. So similarly, if we take cos theta, it is x by z. And if you want to take the horizontal force, then it becomes z cos theta. So this is how you have to consider this. Next, let me show you that how we can write this. This vertical force, we can write it as, for this inclined member, it is Fg sin theta. Next, this one is Fg cos theta. So this inclined member we are converting into vertical force as well as horizontal force. Vertical force means F is at sine theta. Similarly, horizontal force is F is at cos theta. And again, as I told you before, sign conversion, upward positive, downward negative, right side positive, left side negative. So these factors you have to keep it in mind always while solving these kind of structural analysis problems. Now coming back to the point, here we have to see this is the vertical force FAC sine 63.4 degree and this is the horizontal force FAC cos 63.4 degree. Similarly, for this member we have FAD sine 45 and FAD cos 45. So first one, summation of horizontal forces is equal to 0. So FAC cos 63.4 degree plus FAD cos 45 is equal to 0. So we can consider this one like this, like we can convert into one term. So FAC is equal to minus 1.58 FAD. If we find out this one and again we can solve the forces vertically and equate the same. So from that we can find out this FAC value. Again, let's consider joint A and resolving the forces vertically and equating the same. Summation of V is equal to 0. So here we know that FAC value in terms of FAD. Now let's take this force, the support reaction 5 kilonewton plus FAC sine 63.4 degree. From this AC member we are taking one force and plus AD. In this AD, FAD sine 45. So by solving this one, we know that FAC is equal to minus 1.58 FAD in the previous calculation. So that we can apply and we can convert into one term. So by solving this, we get FAD is equal to 7.07 kilonewton. So this member is a tension member. Whatever the assumption we made was correct. And next what we have to do, let's take this value FAD value and we'll apply it in the previous calculation and we'll find out the AC value, FAC value. Again, in joint A, horizontal forces are equal to 0. We know FAD is equal to 7.07 kilonewton. So let's apply here. We get FAC is equal to negative 11.17. So negative means it is a compression member. But we had assumed as a tension member, but actually it is a compression member. Now we know the value of member AC and AD. Next we need to find out the value of DC. For this, let's consider joint D and resolving the forces vertically and equating the same. Summation of vertical forces are equal to 0. So here at joint D we are having three unknown forces FCD, FDA, FDB. These two we already know and only we need to find out this FCD. For this AD, for this member AD, we are having FDA cos 45 and FDA sin 45. Similarly, for this member DB, FDB cos 45 and FDB sin 45. This is the vertical force. Let's consider this is upward direction, upward force. You should consider this sign conversion. So FCD we can take like that only, minus FDA sin 45. See, this force is acting downward, so we should consider negative sign FDA sin 45. Similarly, minus FDB sin 45. This is also in negative direction. So minus FDB sin 45 is equal to 0. Here we can use, instead of FDA sin 45 and FDB sin 45, we can make it as a one term because FDA and FDB are similar. Since it is a symmetrical one, we can consider convert it as a single force. So I'm taking FDA and FDB as a 2 FDA sin 45, and we know FAD value is 7.07 kilonewton. So if I apply that one here, we get FCD as 9.998 kilonewton, which is in tension. We have found out all the unknown forces. Now let's tabulate all the values. First one is member AD, magnitude of force is 7.07. All the force units are in kilonewton. So nature of force is tension. Next, member AC, that is 11.17 and it is a compression member. Member BC, it is also 11.17 compression member. Member BD 7.07, which is tension member. Member CD is 9.998, which is also a tension member. So friends, I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. If you like this video, please hit the like button and also share it with your friends. Thank you for watching.